All right, so we are skipping 6.3 and we're going straight to 6.4. We're going to be talking about central limit theorem. So the central limit theorem allows us to use everything that we've learned so far to make some really important applications and determine whether things are usual, unusual, and start putting everything together. So the central limit theorem states that as we have a sample size larger than 30, everything will start to be normal. Now we have a new formula that we're adding. So notice right here at the bottom that is the standard deviation over the square root of n. That is going to be going under our z-score, which we just learned last couple of lectures. All right, so let's take a look at applying the normal distribution. So something to note is that sample mean now gets moved from population mean of all sample means, which actually just equals population mean. Standard deviation of all values, so is the standard error of the mean. And so really we're doing x bar minus mu over this right here. And so when you're doing this in your calculator, make sure you do this part right here first. And then do the sample mean minus the population mean. Make sure you go step by step in order to avoid any mistakes. All right, so let's take a look at this slide. Original population is not normally distributed. We do not use this section. So we need to check requirements. When working with the mean for a sample, verify that the normal distribution can be used so that the population has a normal distribution or the sample size is greater than 30. If it does not have a normal distribution or the sample size is not greater than 30, and the sample size is not greater than 30, we cannot use it. All right. So we did it for an individual mean beforehand, where we took an individual score minus the population mean over the standard deviation. And so now notice we're going to be going to samples. And so when we have a sample in any question that we're dealing with this, they're going to be giving us a sample size. And so that's how we're going to be able to tell that we're not doing the individual one, but we have to do the sample. And then we're going to use this formula and this formula over here. All right, so we do this, we do means of all values, we covered this, and this bottom part I called standard error of the mean. Guess what? Standard error of the mean. So let's take a look at this. What we're going to do is we are going to go through this question and find out what they're looking for. So we want to find the probability that one randomly selected male has a weight greater than 148 pounds. So that means we need to look for the area to the right. And so in order to do that, we know that our x is going to be 148. By reading through here, we have 189, and then we have 39. And then we'll come back to B, but B is that a sample of 27 randomly selected adult males has a mean weight greater than 148. All right, so the first one's pretty simple. We wanted to see the weight greater than 148. So it's 148 minus 189. We got 189 on the last question because that was 4,000 total weight in the example for the elevator. And there was 27 people. So the most it would be is 148. And now the average male weighs 189 pounds. So we're talking about 189, so that's why it goes here, 148 over here. 39 was the standard deviation, so we end up with negative 1.05, and so we look for the area negative 1.05, and we can look in StatDisk to get this. So we open up StatDisk, and look, negative 1.05, click evaluate, the area to the right is 85%. Now, something else to notice, even if you're doing a single score, you can always do it over this equation over here. Why? Because it's over 1. So it's standard deviation over the square root of 1, which is just 1. So it's the same thing. So if you are confused on when to use this, you can always use this, because if it's just a single person, it's just going to be that same standard deviation. When it's going to make a difference is starting over here. So this is for solution B. Remember, we had 39 as our standard deviation. We're talking about 27 total people. So we have 27. So it's 39 over the square root of 27. Remember to break these down individually. That's going to equal 7.51. All right, so we end up with 7.51. What's going to happen is we're going to really shrink up things. And we're going to find the green shaded area. So we're going to go from 148 and higher. So let's do the math. So we do 148 minus 189 just like before, and that's going to be negative 41. We had our standard error of the mean, which we previously calculated, which is 7.51. And we're going to end up with negative 5.46. So with our negative 5.46, we entered it into StatDisk, and we end up with approximately all the area to the right, pretty much 1. If you do it through technology, or like the slides are going to say, it's going to say 0.999 because we can't be ever certain, but we can here. Just a reminder, analysis, probability distributions, normal distributions is how we get here. So basically we have a 99% chance over 99.999 that we'll have a mean weight greater than 148. So the first interpretation is basically 85%. The second one is 99.9999998. All right, so one thing that we're going to start talking about in either chapter 7 or 8 is identifying a rare event. We talked about this previously in class. That significantly less or significantly greater is going to be based upon these observed events. So if we end up with less than 0.05 or 0.025, it's also taking into account those critical values. So let's take a look at this. Is it unlikely to get this answer right here, or this result? So find the probability of getting a mean of 98.2 degrees or lower when we think that the average temperature is 98.6 and the standard deviation is 0.62. We have 106. So let's go through and start plugging in the problems. This would be a good time to pause this video and try it on your own. Alright, so now that we've got this, we have the assumption that the 98.6 is the average body temperature. We had 0.62 as the standard deviation and 106 as the total number of people. So we do the square root of that, which comes out to roughly, almost 10, just 10 little plus. So that's why we end up with 0.0602. Now we have all the information to look and enter into our analysis. So 98.2, 98.6, put that negative 6.64. Now we were looking for area to the left of it. So we need to go back to StatDisk. So we enter in negative 6.64, click evaluate, and all the area to the left is going to be 0. We never go 0, so we do 0.001, because we never say it's completely impossible, and that is going to be the answer. Therefore, we can conclude that this is an extremely rare event for 106 people to have 98.2 degrees Fahrenheit. Though, to be fair, there is much more research nowadays saying that our average temperature is actually closer to 98.2, which is what this is stating over here, than actually having an average temperature of 98.6. All right. That is it for this section of 6-4. I will talk to you soon in the next section.